Hey, it's Jason Gorman from Codemanship with a special sort of video diary. We're going to be doing a bit of screencasting today, and I'm joined by a good friend of mine, Mr. Will Price. Do you want to introduce yourself, Will?
Yeah, sure. Hi. So I'm Will Price. I've been Jason's apprentice. So he's taught me since my undergrad days. I'm currently towards the end of my PhD now. And yeah, we're just gonna have a go doing some refactoring together.
Cool. So we're going to be tackling the Guitar Shack legacy code exercise, which I used in a workshop a couple of weeks ago, and it seemed to go down quite well. So I'll briefly explain what the exercise is. So we've got some legacy code, and I'll qualify what I mean by legacy code. It is a code that does not have unit tests, basically. Code that would be risky to change or difficult to change because we can't retest it quickly necessarily. And as is always the case with legacy code, if we take a look inside the stock monitor, Will. So we've got this big ball of mud. I'll explain what it does in a minute. But contained within this big, sort of embedded inside this big ball of mud are a couple of external dependencies. So at the moment, we can only test this thing works by actually talking to web services, which is less than ideal. So your typical kind of legacy code problem, basically. So what does this do? This is a very simple piece of logic. It doesn't look simple, I know. That decides whether or not to send an alert to the manager of a fictional guitar shop called Guitar Shack to remind him or her to order more of a particular product. So what it does is it intercepts sales notifications. Let's imagine they're coming from the till in the shop or some other system like that. Before it hits our back-end systems, before it hits our back office, and based on the product ID and the quantity sold, it does a couple of checks and decides whether or not we should order more. So this is intended to solve a business problem, which is we keep running out of stock before we can get more. Every product has a lead time. That is, every time we order more of that product, we have to wait a certain number of days for that reorder to arrive in our warehouse. And during that time, if we've got none, then we're losing sales. So that's the problem we're trying to solve here. We want to lose as few sales as possible. The way it does this calculation, if we sort of take a look at the bottom of the screen there, so we figure out how many we're going to have left after we process this sale. That's the current stock in the warehouse system minus the quantity that we sold. So that's how many we'll have left. And on the right-hand side, that little expression there essentially is calculating, let's call it a reorder level, the number that we would need to hold in stock to ensure that we don't run out before we can get more. So it's the rate of sales over the previous 30 days of that product, the total divided by 30, multiplied by this delivery lead time. How many days would we have to wait for more? So if we hit that level, it will send an alert to the store manager to order more of that product. So that's kind of the business end. But in order to do that, it needs to know details about the product, in particular, how much stock do we hold and what is its lead time. And it also needs to know about historical sales. How many of that product did we sell in the last 30 days? This information comes from two external web services. So you'll see the one at the top there. They've got two different URLs. These are just Amazon Lambdas, two different URLs, one for the product and one for the sales history, which retrieves a sales total. And what I've done is I've just inlined everything into one nasty big method. So the way this exercise works is we've been asked to make a change to this logic. So it currently calculates this reorder level based on the last 30 days of sales. But the problem there is, for example, if we were to sell a product on the 1st of December and look back at the previous month's sales, sales in November and sales in December tend to be very different. We tend to sell a lot more in December. So there is a danger that we will under order because we're not doing it seasonally. We're not looking ahead to how many we would sell. We're looking back to how many we did sell recently. So what they've asked us to do is they've asked us to change the start date and the end date that we look, the date range that we look in. So instead of looking in the previous 30 days going from today, they want us to go back a year and look at the next 30 days. So if we were to sell a product on the 1st of December, we would look up to December the 31st, but in the previous year. So that's the change we've been asked to make. And we'd like to make that change safely. So this exercise is very loosely based on a process that's outlined in Michael Feather's book, Working Effectively with Legacy Code. And the process is all about how do we change legacy code safely. And the first thing we do is we identify where the logic is that we'll need to change. So I'm sure Will can highlight the code that's doing the date stuff.
So this stuff around here.
Yeah, so down to there is the logic. That's where we pick the start date and the end date. So that's the code we want to change. So we identify that. Then we need to think about, well, if we were going to write tests to reassure us we haven't broken this, what would we test? And we don't really have a lot of choice here. We've got one class that does stuff. And the clue to that might be if we take a look in a class called program. So what we've got here is we've got a command line program that is essentially using the stock monitor class that's doing all the work. And we can run it with a particular test case with a particular example. So we would probably have to write tests for that stock monitor. I don't think that is the entry point, and we don't have anywhere else to go. So that's where we want to write our test. Now, in order to write the test, we're going to have to do something about these nasty external dependencies. So the next part of the process is to refactor stock monitor so that it is possible to stub those external dependencies for the purposes of unit testing. So we refactor it to make it unit testable, and then we're going to write those unit tests. We'll probably dream up a sort of a system test, and then we'll reproduce that as a unit test when we get to a point when we can. Once you've done that, you're in a much better place, basically, because now you've got fast running tests, which should make the going a little easier. There is a bit of a danger zone where we don't have fast running tests, but we need to do some refactoring. When we get to that, you'll look at what we do to try and keep ourselves reasonably safe. So we write the tests, and then in a nice test-driven way, we make the change that they've asked us to make. So we'll write tests that fail because the end date and the start date are going to be different. And then we'll fix those tests to make it do what they want. So step one, identify which code needs to change. Step two, identify where you'd want to write tests to protect yourself against breaking that code as you work on it. Then write those tests, which may involve refactoring the code to make it unit testable. And then in a test-driven way, make the change that you've been asked to make now that it's possible to unit test that. And then now that we're in there, now that we've got fast running tests and we've done a bit of refactoring in there to make the code a bit more modular, we apply the Boy Scout rule, which is that we always leave the campsite cleaner than we found it. So we're going to carry on and do a bit more refactoring in between the stuff that we're stubbing and our unit tests to make change easier for the next person that has to change this code, which might be us. So that's kind of the exercise. First thing we need to think about before we even think about changing this code is how are we going to test the stock monitor until we can get unit tests in place. Now, opinions differ on this. There are people who say that if you're using automated refactoring, you don't need to retest the code. As you're about to discover, this is bad advice because automated refactorings are not guaranteed to not break your code. And I suspect there's at least one refactoring we might do today that probably will break our code because there's a little bug in it. So we are going to retest. We might not retest quite as rigorously or quite as often as we would if we had unit tests, but we're not going to wander too far from seeing this thing work. So the first thing we need to think about is how could we test this thing with what we've got? We've got this main method. So we could run this if we set it up with a couple of parameters, basically. If we give it an existing product ID and a sales quantity that's going to trigger an alert, we should see that message you see on line 8 and 9. That should be written to our console if an alert is being sent. Okay, so let's see if we can set that up. Now that we've set the scene.
Okay, so Jason, you're going to have to remind me what
Okay.
your
Well, a
product
good
ID
one to go
is.
for is 811. So that's the Les Paul Classic.
Let's see, program arguments 811, and we'll order, let's say, 100 of those.
Yeah, let's run out basically. And that should definitely trigger another. So when we run this, we should see, you see there the message that's triggered. So at the moment, we're not actually sending alerts. You can imagine we might be sending an email or a notification to a phone or a text message. But at the moment, it's just an interface. So we're faking that for now, as you'll see from the comment on line 6. So all we're actually doing at the moment is just printing it out, just so that we can see what happened. Okay, so we're good. I think that's going to give me reasonable confidence, because I think that hits pretty much every line of code. That gives me reasonable confidence that the thing will be working as we go. So we're going to run that command line program a few times, definitely, as we refactor. So let's take a look inside stock monitor. So our priority now is to make this unit testable. So we probably need to refactor it so that we are not connecting to web services.
Okay, so initially we have this code that builds up the URL with a query param string. And it's only sort of around this point here where we actually send that query. So really the most minimal part of the external, the interaction with the external dependency is line 41 here. But we're probably better off pulling the construction of this HTTP client and the response out, as these all are around interacting with that external dependency.
Okay. What about the HTTP request part? So technically that doesn't, but I'm just wondering, there might be a quick win here, because if we scroll down, we see there's a block of code that's almost identical.
Yeah.
And that's starting from the construction of the parameter string. So there might be a quick win here to just remove some duplication, because IntelliJ might be smart enough to spot this duplication. So I'm wondering if we go from line 29, so it's quite a big chunk that we're stripping out here, but it is duplicated. So this might be a quick win.
Okay. So,
I like a quick win.
So this can be our send request method.
Mm-hmm.
And it takes a base URL and params, which seem reasonable names for the arguments of this method.
I think so.
And IntelliJ's picked up that repeated occurrence, so we can also pull that out.
There you go. So there's a quick win.
So
and that might make life easy for us going forward. At this point, at this point, my instinct would be, let's see that work. So while we might not do this for every single refactoring at this point, I think it is, I've learned from bitter experience that you should never wander too far from seeing it work. Okay, so far so good. So it's in its own method, but we want to make this stubbable. So it really needs to be
in its own class.
In its own class, yeah.
So I think we can
a number of routes we could take here. Yeah.
So I think we can extract a delegate here. So we'll end up with an object that actually handles dealing with sending the request, which this method will eventually live on. So
I would agree. Although, but full disclosure, we've tried this before. So this isn't our first rodeo. But so having looked at this again, I tried it again this morning, and we kind of tied ourselves in knots a bit, because we had one instance of this thing that handles HTTP requests, and then when we were stubbing it, we had to do some fancy shooting to get it to return 2 responses in order with different base URLs. And now that I'm thinking about it, I'm wondering whether it would be better to have 2 instances, each of which has its own base URL, so that we don't make them order dependent on each other, because that I found that took us down a rather fiddly road when it came to using the stubs. So
yeah, that's probably better, because then you kind of want to wrap up that URL as part of the object that deals with interacting with that service. It's probably, from a design perspective.
I think you're absolutely right. So I'm wondering if we could take a rather than using, so extract. Do you want to explain what extract delegate does?
So extract delegate is going to create a new class and pull this method, this send request method, into that class. It will leave this method here, but it will change its implementation so that rather than having the code we have here, what it will do is refer to a instance of the object, the delegate that we create, and pass on the send request message to that object.
I think probably now that I hear it, it's probably easier if we show them.
Yeah, probably. Easier to show than to describe.
Is often the case.
Right, so this could be a repository.
Are we going into domain-driven design territory here?
Maybe.
You gave it a name before. You called it a service.
Service. Okay.
Yeah. So that's what it does. It's basically it's extract class. So it'll extract whatever features we tell it to. It'll move those to this new class. It creates an instance of it, which in this case is a shared instance because it's referenced. It's used twice. It has to create it as a shared instance. So it creates it as a field, and then it leaves the original method behind, presumably so as not to break client code. So you're not unpicking a whole bunch of different client code. It leaves the kind of the original interface. So hence it's not called extract class, it's called extract delegate. But in this case, I'm not sure it's the right way to go. So we'll undo that. And let's just rerun our command line program just to reassure an old man. As I get older, the test runs get closer and closer together until eventually I'll be so old I won't be able to actually do any coding. Too busy running the tests. Okay, so there's another way around we can do this with a little sequence of refactorings where we could extract a service object that has a base URL.
Okay, so so we want to extract a parameter object, I suppose. So the idea would be that eventually what we want to do is end up with a parameter to this method, which will be our service class. And then that gives us a target to move this method to. And then, so to do that, the introduce parameter object refactoring is quite useful because even though you might not necessarily be wrapping up a number of parameters, it gives you a way of having the target class that you want to move a method to as part of your method signature. So it's an intermediate step in the refactoring.
Yeah, and it's a good way of discovering types of objects. Often I will start by introducing a method, and then look at that method's parameters. Because if I come at objects from sort of the work first, then the data way round, which I think it tends to work better. So you start by saying, well, look, we've got a method here or a function that does this work. What data does it require in order to do it? And then you can then sort of draw out an object that has that data and then move the method to it so it does the work, and then you can encapsulate the data. So it's one I do a lot. Okay, let's do that. You're a little further up. Yeah.
Okay, so we are service object, and we're going to just keep the base URL on it. So the parameters should necessarily be part of the send request method
Yeah. So
signature.
parameters are transient in the sense that they can change during the lifetime of this object.
Okay, so let's just run that.
Now we're very lucky here in the sense that our system test in inverted commas doesn't take very long to run, but you can imagine for a real piece of software what a pain in the behind this might be. But trust me, far less painful than what can happen when you don't run the tests at least every few minutes. Okay.
So I think now we're probably going to have to pull this out to a variable.
Mm-hmm.
Let's do that. So this will be our sales service. And we can do the same for our product service.
Precisely, yeah. So they can't be the same instance.
Okay, so now we've got those. Let's just run our main method again, make sure things are still hunky-dory. Okay, so now we should be in a position to move this method over to this class. So we can do that.
I love this refactoring move instance method because it's the one that explains what object-oriented actually means. Because you start with action object, do this with this object, or do this to this object, and then it flips it around and puts the object in front. And that's basically what we mean by object-oriented. People often read it the wrong way around. They read it backwards.
So we've got a few extraneous methods here, like this get base URL. So let's just double check that we've only got one use case of that. So we've got one use case, and that's internally within the object. So we can just go ahead and inline that. So
when Will did that introduce parameter object, it would have introduced the base URL as a field, but then it would have had to have exposed it with a getter because the code that was using it was still inside the stock monitor.
Okay.
Okay, so far so spiffy.
Okay, great. So now these are just currently variables of this method, but eventually we want to be able to pass these services in. These are wrapping up our external dependencies.
Yeah.
So to get to that point, if we introduce them as fields and then instantiate these objects and pass them in via the constructor, then that gives us a way of injecting our swappable dependencies, so our mocks or stubs. So
I've had another thought here, Will. I've been milk and cookies have been keeping me awake. So when we did this last time, so we were introducing these quite low level dependencies using dependency injection and size, but then we had to kind of unpick it because they are low level dependencies, and eventually there'll be dependencies of something higher level. So I had a thought, maybe at this point, because it wouldn't be such a big deal to do, now is the time to really chunk stock monitor, and because it has kind of two sub jobs that it does. One sub job is figuring out what that reorder level is. And the other sub job is getting the product in order to figure out the reorder level. So my feeling now is, so rather than having our two services passed in as parameters to the constructor of stock monitor, maybe if we break down these two chunks first, and then we can create two new objects that do those higher level jobs, and then we're left with a stock monitor that's not concerning itself with web services at all. So just to make life a little easier going forward, I think pretty much everything from line 20 down to line 26 is just about getting the product. So we can do that one first.
Okay.
Okay, good stuff.
Just inline that.
Inline that. Yeah, very good instinct. Well, Will is very well trained. I don't know by who.
Who trained me?
Okay. Even though he's had years and years of a PhD to try and beat him out of that. Good.
Yes. Somehow I've retained a few good habits Jason's taught me.
It's like riding a bicycle, Will.
Okay.
And so I'm thinking, because we get the sales title, but I'm wondering whether we go a little further. So that on line 36, the expression on the right-hand side of the conditional is essentially the reorder level, whether we want something that just calculates the reorder level. So if we were to draw that out.
Well, certainly we're going to want to pull that out.
You'll need the int as well, I think. I think it's
Yeah.
got to be an int. Yeah.
So this is our reorder threshold. Okay.
Okay. And then I think before we run the test again, I think then if you pull out all of that code down to line 36, then that's another nice big chunk. So from 21 all the way down.
Yeah. Okay, so the get reorder threshold.
That'll do for now.
Or maybe I said this last time we attempted this. I was complaining about the method names. So I didn't like get because we're doing
yeah, I
networks.
agree.
So
get has in the world of Java, get has implications.
So we could either have calculate reorder threshold. Okay, and let's run our program. Make sure we've not broken anything. Okay.
Okay. Just before we go any further, can we rename? Can we inline reorder threshold? And also on line 21.
Yeah.
The only reason I'm saying that is because eventually this stuff's going to get renamed. We might get tripped up by having an object and an integer with the same name.
So this up here is starting to look quite good. So we have a stock monitor. It has an alert, and we want to determine whether this alert should be raised based on the product and how much of it we've already sold. We get the product. Here we should probably let's pull this out. So this can be our
remaining stock, unsold stock.
Yeah. So if our unsold stock is below our reorder threshold, then we send an alert. So that's quite nice and intelligible.
I like to think so.
Okay.
So now we've got this sort of bird's eye view now of what it looks like, or what it should look like. And what we're doing is what I call this process chunking. We're just pulling off big chunks of it. And now we can think about pulling these chunks out into their own classes. So we need something that is responsible for calculating the reorder threshold that uses the service. So we can remove the dependency on service from stock monitor, because I don't think it should know anything about it.
Yeah. So how do we want to go about this? Are we going to extract a get delegate, or are we going to go down the introduce parameter object route?
Well, I guess the question there is whether there are any parameters of this that we would say were fields of this object, and I don't think there are. I think the product will change every time we call it. So I guess in that instance, extract delegate is the way to go. And we're about to witness what happens when you don't retest because you mistakenly believe that your automated refactoring will not break your code.
So we can put this reorder threshold. So we've pulled that out.
That's not going to compile, I think. There you go. So I don't know whether it's something to do with the scope of those puts, because they're inside a
probably
lambda essentially. But yeah, it breaks the code. So
yeah,
you need to watch out for that kind of thing.
Anonymous in a class, aren't they?
Yeah.
Have they added some new stuff to one of the later Javas to improve this? So all that up to date on my Java.
We can probably get rid of that.
Yeah, we can clear those out.
Okay. So all we're doing is we're really just saying we want a big chunk of this somewhere.
And we can get rid of that empty constructor. There's no need for that either. Okay. And let's rename this because we've got, if we come back over here, we'll see we have reorder threshold.calculate reorder threshold. So it can just be
object oriented. I see that a lot. The name of a class with a verb in it, followed by the same name, but with get or calculate or something like that. There should be no need for it.
Okay, and I guess we do the same for get products. So let's extract delegate. This is something that we're going to get products from, so we can call it warehouse. And let's just oh, here we go. Same issue again.
This is why we retest.
Okay, and we can get rid of that constructor. And now we have this unused get product. Get rid of that as well. Okay.
Okay, not bad, not bad. Now, if we wanted to unit test stock monitor, it's still, because these dependencies are hardwired, it's still going to hit those external systems potentially. So we need to, what do we need to do, Will?
Well, we need to pass these in through the constructor. So we need to do dependency injection. So we can initialize these in the constructor initially as one step towards that. And we can introduce these as parameters. All right, now that was quite a lot of stuff. So let's just run that and see whether I broke anything. Okay, we look all right still. So now when we instantiate this stock monitor, we should be passing in the reorder threshold, the warehouse.
Mm-hmm.
So things are looking a bit better there. And
still not unit testable though.
No, because we're still, we don't want to mock out reorder threshold or warehouse. Instead, we want these, we want our services to be dependencies of each of these classes. And those are the things that we can stub out.
Okay.
So let's do that. So for our sales, so we'll turn sales service into a field and instantiate it again in the, a bit awry there, instantiate it in the constructor. Okay, seems it's created too. Let's just tidy that up and run the code. So we can then make our service also injectable by introducing a parameter here. So now the way that we get the sales total is through this send request on the sales service. So that's something that we can stub out, and that will enable us to unit test the whole thing. And we need to do the same thing for the warehouse here. So we're going to turn the product service into a field. And let's see, is there any automated refactorings here? Or I guess not. So in that case, I'll just write myself constructor.
I'm curious that it didn't give you the choice then.
Yeah, I've not seen that before. Strange, isn't it? Okay, so let's just, because base URL.
If you inline that. So let's step back.
Yeah.
And we'll do it all again, basically.
Yeah, okay, let me go all the way back. So let me just run the code. We're still good. Okay, so let's inline that base URL. And we should be okay to turn that into a field. Tree instantiate constructor. And now we can pass that in as a parameter. And if we go back in to our program, we've now got our warehouse and our reorder threshold, both where we've externalized these service dependencies.
Yeah, yeah.
So this is getting a little messy. Let's pull these out to variables. And let's do the same for the alert as well. Okay.
So far, so good. So we're in a position where we could, for example, extend service and override its methods. So it's kind of stubbable, but I think really we should go a little bit further with this one because these are external dependencies. So we probably want sort of much greater sort of swappability for service in particular, because it does wrap up this external dependency.
So should we extract an interface then?
Mm-hmm.
Okay, so let's do that. Extract an interface. So send request is going to be on here. And let's see, what shall we?
I'm just wondering, maybe if we rename.
Yeah.
So we call the new one web service, REST service.
Okay, let's just take a look at our interface. So it's got send request and takes a string. I mean, we can revisit this later. It'd be nicer if this was some sort of typed service, so it had
it would be nice if it returned a product and stuff. That would be great. But we're not here to fix that problem yet.
Not yet, no.
Not yet. So let's plow on. So we're in a position now where if we wanted to, we could very easily stub those services, their responses, for the purposes of a unit test. So I guess the next step would be to create that unit test.
Okay, let's create test folder and there's some automated thing.
If you type out test, it normally does do.
Yeah, I thought so. Oh, am I? No, it doesn't.
No, okay.
Okay, so what's our first test? I suppose we want to test that when the current stock is below the reorder threshold, that the alert is sent. So
yeah, that's essentially what our system test is.
Okay, so when current stock is below reorder threshold, so let's see, what do we want to do? Well, we essentially want to ensure that some alert is sent. So how are we going to do that? Let's just revisit our alert interface. So that has this send in send method. So we want to make sure that is called.
Yeah, yeah.
And we can use Makito to do this. So I'm just pulling up the docs on my other monitor here. That's to verify, isn't it? So we want to verify that alert is called. The send method on alert is called, and to begin with, we'll just
yeah. We at the moment we just care that it's invoked. We're not too bothered about the actual contents of the alert.
Start it. Okay. So now we need to create our alert, and we can just mock the alert class. Okay. So now we need to create our stock monitor. And we need an alert. And what else do we need? We need our reorder threshold and our warehouse. So let's create our reorder threshold. And that needs a service. So our sales service.
Yeah, we can just do an anonymous. So we do new service and just
right, yeah.
So we'll generate an anonymous in a class. That's right. You can just use a lambda.
Yeah. I was just going to say that because it's a functional interface, isn't it?
But let the tool do the work there. Just do new service and it'll do that.
Okay.
And then we can refactor that afterwards.
Okay. So in this case, we
so what it would return JSON with a total, basically. So if you take a look at the sales total class, that's essentially the data object that it's deserialized into.
Let's see, so we do sales service and request. Okay, and then we get this sales total. Okay, so if we return JSON object with a total field, and this is.
So this is used to determine the rate of sales per day over 30 days. So if we said, for example, 60, that's two a day. That's the rate of sales, 2 a day.
Okay.
That's all we need to do for that. Now it's hinting there that there's a simpler solution. You'll see where it's grayed out there.
Mm-hmm. Oh, we should have just written that in the first place. Okay. Right, and now we need to do the same again for warehouse. And just hard code our response here. That's also going to be some JSON. So let's go have a look at the warehouse to see how that is functioning. So we're deserializing a product here. So it's got a stock, an ID, and a lead time. So we want to make sure that the
stock and the lead time are the important ones there.
Yeah, so we get the total, which we've said is 60 divided by 30, which is 2 times our product lead time. And that's our reorder threshold.
Yeah, and if our lead time was, I don't know, 14 days, that would mean we'd need to hold at least 28.
Yeah, okay. So let's have our ID. Let's use the same product ID that we've been using in our before. Okay, and then we're going to need a lead time. So yeah, let's go for 14 days, like you said, and the current stock level.
So let's put it right on the edge. If we're selling 2 a day, that means our reorder threshold is 28. So let's say we've got 29. We sell 1.
Or do we want 28, or does that mean that we should have already raised this alert?
Yes.
Okay, so 29. Okay. So we can. So if we sell 1.
That should do it. He said that should do it. That should do it. There we go. Bish bosh, our first unit test. So we're kind of reproducing what we had before when we were running it at the command line. But now that we're here, it might be worth writing another test for when an alert isn't sent, just for completeness.
Yeah.
So maybe.
But before we do that, as I always like to do, well, we've not seen this fail before, right? So I just want to gain some confidence, especially when we're doing stuff on legacy code, you know. So let's bump our stock up massively. This shouldn't cause our reorder threshold. Okay, so it failed in the way that we would have expected it to fail. The alert was not sent. So that gives me some confidence that this is indeed working. Okay, so yeah, let's write that other test. So when current stock is above reorder threshold, an alert is not sent.
You got is not send there.
Okay.
So quick win here. Just if you turn alert and stock monitor into fields.
Okay, alert. And
in current method is fine,
yeah.
And stock monitor. Then you can strip out that setup into its own method. Don't forget to run the testicles. Now that we've got it.
Okay, and let's pull.
And the stock monitor as well.
Okay. Can you remind me the JUnit annotation?
Before, and it needs to be public.
Okay. I'm guessing it's going to tell me that. Yeah. Okay.
So that should make the next test a little easier.
So if we sell 1, but this time what we're going to want to do is change our warehouse stock.
Well, if you change the warehouse stock to 30, and then in the first test we sell 2, and in the second, in the next test we sell 1, that should do it. It'd make more sense than selling none.
Yeah.
So there's a verify never called, or so this it's the name of the method, verify never, or.
Oh, okay. So send what?
No, verify. No, literally the name of the method is verify never something or other. I can't remember what it is.
Oh.
Verify no more interactions.
Like that?
No, you don't need to worry about the send. It means if any method at all is called on that, this will fail.
Oh, right. Okay. Hang on, that's only testing the 1 test. So I'm running. Okay, so both. And let's just, again, I want to see this fail. So let's bump this back up to 2.
Okay.
And see, no interactions wanted here, but products.
somebody interacted with them all.
Okay.
Okay. So we have got tests around this thing. That's the next step. So we're making good progress. I'm gonna briefly pause recording on this now so we can take a comfort break, and then we come back. We're gonna make the change. Okay.
Excellent.
See you in a bit.
See you in a bit.
Welcome back. We had a little comfort break there. Highly recommend that, especially on if you Zoom as much as I do. It's killing me. It really is. Okay, so we're in a good place now in the sense that we've tackled these external dependencies. We refactored to make it easy to stub the responses from these web services, from these REST services. And now we have a couple of unit tests that cover both sides of that logic, whether the alert is sent or is not sent. So that gives me some confidence going forward that if we were to break this thing, we would know. Now our priority is in a nice test-driven way to make the change that we've been asked to make. But in the refactorings that we've done by chunking out that stock monitor class into these bigger things, it turns out that our date logic there is more isolated than it was. So we probably don't need to unit test it at the level of the stock monitor because now it's a concern of this reorder threshold. So thinking out loud, we could probably maybe write our failing unit tests for this class. What do you think?
Yeah, that sounds good to me. So let's, so how would we do that? I suppose we'd stub out our sales service with, well, actually, no, I guess we want to mock it out and check that the start and the end date are correct.
Yeah, so there's a chunk of code here, isn't there, that's really just about getting that sales total.
Mm-hmm.
And if that was in a separate class, it would then be possible, if that was being injected into the reorder threshold, it would be possible to use Marketo to check what start date and end date it's being called with. So if we make this class responsible for figuring out the date range,
mm-hmm.
and then we can catch it there.
So we would want to pull all of this out. So let's extract that out to a method. Be our fetch sales total. And let's extract a delegate now to break that out into its own class.
Before we do that, keep an eye on its dependencies. It has an internal dependency using the sales service.
The sales service. Right,
so
I see.
If you're going to, so there's a bunch of ways we could do this. We probably wouldn't be able to get away here with extracting that with the sales service field because of the fact that it's set in the constructor here. Or I don't know. Maybe.
I think it will be all right because it should instantiate the delegate within the constructor passing in the sales service. Yeah. Maybe. I mean, that's what I hope it will do, although it might add a getter.
Well, we can always hope.
It might add a getter on this and pass in itself. So
I have a good, horrible feeling it will. So if we extract delegate and pass it, so give it the sales, so it's warning us now that we can't have fetch sales total by itself. It needs the sales service. So if you select that as well, no, it's fine. You can select the sales service as well. So extract delegate will take a bunch of features if we need it to.
Okay.
That satisfies it.
Yeah, good point.
Sales history, good name. Okay. Yeah, I had a feeling that would be the case. Okay, there's another way we can go around this. We really want this method to stand on its own 2 feet.
So shall we make sales service a parameter of this method, and then we avoid that internal dependency?
Yeah. So this is usually a good way of going about it, is to just check you know, what does it need that's already defined in this class? What features of this class does it need? And make them parameters.
So we should now be able to extract that delegate.
Nope.
No?
This is a move. This is a move. No, you're right. No, I'm good. Or unless we want the service to be passed into the sales history, in which case we might go around a different way. So what if we introduced a parameter object that has a sales service?
Ah, yeah, that's a better route because that handles, because we're going to get in a bit of a mess otherwise. If we extract a delegate, we'll end up with fetch sales total, still having this service.
And then we're going to have to rewire it all from the top. So
going via the parameter object is much better this way. It's like whenever you want one of these parameters to end up being a field of the object that you're going to create, then this introduce parameter objects.
So the question you're asking yourself really is sales service immutable in terms of its relationship to sales history? If the answer is yes, then this is maybe a better way to go. Of course, you can only do this when you're extracting classes that have only the one feature. If there's multiple features, you have to use extract delegate.
Okay, so we're going to take the service with us. Okay, and just run the tests. And now we can move this over to our sales history.
Okay. So I originally invented this for a workshop that was not about refactoring, it was actually about modularity. And one of the questions that keeps coming up is, what is object-oriented programming? And I think this exercise is a good way of explaining what we mean by object-oriented, what it really means. That we're essentially we're identifying responsibilities first, and then refactoring to introduce the object to which that responsibility belongs. And it's often and that then constructs our little collaboration of classes quite dynamically based on the collaborations that need to happen in order to do the work. So it's all very responsibility driven. And there's, in fact, responsibility driven design is a thing. And there are many people who say that, well, that's what object oriented design really is. It should be, it's not all about, you know, a zoo has a keeper and it has exhibits. It's all about what does a zoo do? What do we need a zoo to do? And therefore, which parts of the zoo should be doing which jobs? And it always seems to work better when you start with what job needs doing and then identify, okay, and what does it need to do that job? And objects essentially just put the two together. You put the work, you encapsulate the work with the things that are needed to do that work, so we can expose as little as possible about them. It's a fundamental misunderstanding about object orientation, that it starts with objects. It doesn't. It starts with work. As should all software design. Should never start with the data. Never start with the data. Okay. Brilliant. So we have got the sales history. It takes a sales service into its parameters, so that would be swappable.
One thing I have noticed is we've got a slightly smelly setup here. So we take a product, an end date, and a start date. So that could be a bit backwards. So let's just fix that first. And let's take the start date before the end date. So that's a bit more intuitive.
It's all about the details.
So let's come back here. So yeah, we have the sales history and we want this to become our dependency, the dependency that reorder threshold interacts with. So currently we've got the sales service being passed into reorder threshold and we construct our sales history here, but really we just want to push this up the call stack so that reorder threshold has one dependency and that's just sales history.
Yeah.
So let's do that. So we want to make sales history into a field and we'll initialize it in the constructor. So now we've got that. One thing we learned doing this exercise before is if you want to introduce a parameter passing in the sales history, to do that, we need to make sure that all the call sites actually assign sales service to a local variable. Otherwise, the refactoring is unable to work.
There needs to be a service in scope within the client. Otherwise, because we're trying to introduce a parameter that takes a parameter as a parameter. And in fact,
given that it's quite confusing to describe, why don't we just show what happens?
Yeah.
I think with a lot of these things, it's a bit too hard to articulate it in words. Yet when you actually see it, it's very clear what's happening. So if we try and introduce a parameter now, let's just go have a look at one of our call sites. In program, we have this REST service that we pass in. So this is, this isn't assigned to a variable, and this is precisely what will cause an issue. So if we try and turn this sales history into a parameter, so we've just done that, and okay, it's worked this time. That's interesting. Maybe I have a new version of IntelliJ.
Did it do that itself?
Let's undo it. I believe it did. Yeah, it did it itself.
Have you updated IntelliJ recently?
Maybe.
Because it won't do it in mine. Well, that's rather good.
Oh, okay, excellent. So we just
discovered an update to IntelliJ.
Wonderful.
So normally it would kind of half do it. It would refuse to do it in here.
Yeah.
But then it would still introduce the parameter in the client code. And what we discovered was it was looking for something in scope called sales service that was of the right type, but it seems to have actually introduced it itself now.
Excellent. Oh, that's good. So, okay, now we've done that. Let's just run the tests, make sure it still works. And as this is changing the program, I'm also going to run our, I guess our smoke test. Okay, so that's still running. Excellent. Okay, so we've got our sales history here as an external dependency, but we're still passing in the sales service.
Yeah.
Now,
which we're no longer using. Yeah.
So we can delete this field and remove this superfluous parameter. Let's run the tests. Okay, so now we've only got our single dependency that reorder threshold interacts with, and it's the sales history, which is what we were aiming for. So we should now be in a position to write a failing test to update how we handle the sales total. So our reorder threshold is currently implements the logic to determine what the start and the end date of this sales period is.
Yeah, so this is the code we've been asked to change.
Okay, so let's do that. So we want to test that let's start with the start date, shall we? Or do we want to check both the start and the end date in a single test?
I will leave that to your good judgment, Will.
I'd rather have two tests.
Yeah, I'm kind of the same. It would be very easy to reuse the setup, so let's just write one test.
Okay, so we want what do we want? We want the sales period to begin a year prior to today, right?
Mm-hmm.
So
same date last year, basically.
Yeah. So we want to test that the sales total begins same day last year.
Mhm.
And
so we're back in mock territory here, I think.
yeah, so we want to check the interaction with our sales history. We want to make sure
Let me verify.
Yeah, thank you. Fetch sales total. We won't check the product.
Any products, yeah.
And then I guess we'll just code the start date.
So here's a weird thing about, it's not really weird, but if you use any matches in a verify statement, they must all be matches. So you can't just have start. You have to use the right match. I think it's just EQ for equals.
Yeah, I think we came across this last time we tried this, didn't we? Okay, so let's pull these matches in.
There are so many matching matches.
Okay, so we want our sales history, and this is going to be a mock. And then we want our reorder threshold. Used Python too much, forgetting the news.
It's even worse with Kotlin programmers.
Oh yeah.
Yeah, it must get so confusing that all the libraries are pretty much the same.
Okay, so yeah, let's create a product. What does the product have? An ID, a stop and a lead time.
Now, in this case, none of these things matter.
Well, let's put okay. So our start date,
here's where we go down the rabbit hole.
So I believe this date logic here is using, I think, an old version of the Java Date API. So I believe that they introduced this, people hated it, then Joda time came out, and then they recognized the usability improvements that Joda time brought about, and then there was a new Java enhancement protocol that or Java enhancement, what's the P stand for? I can't remember. But there was one of those that introduced a new API for doing date time stuff that's a lot fewer foot guns, shall we say?
Yeah.
So this is something we found quite challenging practicing this exercise. So let's get our new start date then. Right, I think it's a Boolean, and this will be the date. How shall we construct this then? Because the problem is currently we have this calendar that we get an instance of, and then we get the time from it.
Yeah.
And we use that to set the end date and the start date. So at the instant that this line will run, that will get that instant in time, because a calendar is a frozen object. It doesn't tick away as time ticks. So as we interact with it down here and we get the time, from line 14 onwards, it's deterministic what will happen. So this get instance, well, actually, no, that's not entirely true because we have another get instance here. So
the thing is, the start date and the end date are relative to the exact instant of that call to get instance on line 15. So it's all fixed relative to that. But the problem is that it doesn't just match sort of, year, month and day, or year, month, day, hour and second, minutes, etc. It matches it to the millisecond. So everything gets tied to that first date that you set. And so we need a way to fix the time in our test so that the dates that we create in our test are to the millisecond correct as well. So they both match, which is a real pain in the arse. So for that reason, and for many other reasons, we need a way to fix the current time for this test. So that needs to be swappable as well. We need to be able to stub that so that we have a calendar in our own test code that's an exact match in terms of, minutes, seconds, and milliseconds to the other dates that are going to be used in here. So it needs to be part. We can't just get the current time here. We have to pass that in somehow. Okay. It's generally good practice if you've got date-driven logic when you're testing it to make it so that you can fix the data in the test. Otherwise, you can get yourself into all kinds of problems. But it's particularly true with Java dates, because as you said, it's all driven by this frozen calendar. And so if we add a year, we have to remember that we're not just adding a year. It's not just that it's on the same date in the same year. It has to match to the millisecond.
Yeah.
Day.
So we need to essentially pull out something that's going to encapsulate the calendar, and this will become a dependency of reorder threshold. And that will allow us to swap in our fake or stub.
Yeah. So instinctively, I think we need something that gives us the current time. So something that gives us a date. So this thing can take a date and then everything is relative to that date, to the millisecond. So on line 15, I think that little expression there, calendar, get instance, get time, if we could strip that out somehow so that we have one version of it that does it for real and another version that we can stub.
Yeah, okay. So, okay, let's just... So what should we do with this test?
Well,
should we just comment it out for the time being?
Yeah, let's put this to one side. And we can refactor because we've got unit tests at a higher level.
Mm-hmm.
So let's do that, and then we can get back to this test.
Okay, so if we pull out a method to get the current date.
Mm-hmm. Don't. It's trying to be clever. Spotted an opportunity to generalize, but we don't want it to do that.
Okay. So now I suppose we just want to extract a delegate.
Yeah, this one's a pretty easy one, I think. Yeah.
Okay, so current time.
Mm-hmm. Seems reasonable.
Okay, and then let's see, so we've got our current time method. And then I suppose we can just rename this to .get.
Yeah.
Okay, and we can get rid of this superfluous method here in the tests. Okay, and now we want this to be something that we can inject via the constructor.
Yep.
So let's initialize this in the constructor and then introduce this as a parameter. Let's just take a look at the call sites now. So we're just constructing this current time here and passing that into the reorder threshold. I think that will be enough to get us back to our test now.
I think so, yes. Well, again, current time is a class. So we could ask whether it is worth having an interface for this as well. I tend to treat this stuff as sort of external dependencies. As more generally speaking, I would want to abstract away things that change beyond our control. I was thinking a lot about this, about what kind of code makes me think this should be very abstracted. And there's two kinds of code that I think should be. One is code that has a very low correlation with the problem domain. In other words, it's usually about some external library or some external dependency. So you can usually tell by the language. The code that changes beyond our control, or things that change, and the current date changes beyond our control. We can't easily fix the system time. So there's a sort of a general theory there. But it would make it much, much easier to stub. I mean, we could stub this with Mockito, but you'll notice when we run tests with Mockito involved that we get lots of warnings, because for code generation, stubbing and mocking classes, they use cglib.
Yeah.
And they're not supposed to anymore. So somebody at Mockito has got a big rewrite coming.
Oh dear.
But generally speaking, if you're mocking or stubbing something, it's usually, if you're forced to do that, it's usually a hint that maybe that should be more abstract. Otherwise, we're going to go down the inheritance rabbit hole. Or down the Mockito can't do that anymore rabbit hole.
Okay.
A lot of code is going to get rewritten.
So, wait, oh no, wrong. So it's extract an interface. It just seems a little weird extracting an interface for the current time, because what beyond stubbing things out for tests, I can't really think of why you would have a different implementation beyond what we currently have.
Well, you just mentioned one, which is that Java has updated datetime API.
But then you would probably just change.
Yeah, you could, or you might have to support multiple versions of Java, multiple versions of JVM.
But this interface is going to be bound to the old date time interface anyway, because we're returning a date here, and I think it's an instant is the
okay, so
subsequent representation.
Well, if they've not retained date, then no one's going to use their new library.
Well, I mean,
that's a massive rewrite. But generally speaking, if you need to stub it and mock it, that's often a hint. It should be. I'm not afraid of having interfaces purely for testability.
Okay.
It's a good reason to have them, I think, sometimes. But my instinct about date logic is that it should be abstracted anyway.
So what would you name your interface in your class then in this case?
Well, maybe call the implementation system time.
System time or system current time?
I think system time is probably what we would understand by that. Probably. You can, yes, current system time. It's fine, but
yeah, I prefer that. It makes the get a little less ambiguous. Okay, so we can come back to our test now, and we can actually set up our start date. So when we set up our reorder threshold, we're going to have to pass in a current time.
think
Let me just do this. So let me just, we just want to return target type of line. Oh, okay, hang on, let me just stop this for a second.
so. I don't think it accepts an interface as a parameter.
No, let's just go back a second because I believe, yeah, we found.
Yeah.
So if we change this.
Oh, there's an easier way actually. If you, and I would uncomment out the test code as well, because the refactorings you're doing, it can't see it. Can't see the client code. But if you take a look at current system time, let's take a look at current time. Sorry. There's a refactoring called use.
Hang on, we don't have the get on current time.
Yeah.
I think I must have missed that when I extracted an interface.
Yeah. You can do pull up.
Okay, let's do that.
Yeah, I do that quite a lot. Just there's a quick get out.
Pull members up. Okay, yeah, there we go.
And so now if you there's a refactoring, I can't remember if it's the class level. So if you select the current system time class, take a look on your refactor menu. There is one called use interface where possible. And that's a kind of a one-time thing that you can do occasionally that just replaces all the references to it.
Okay, great. So now we should be able to return current time. Okay, so in this case, I think we can just get our calendar, get the time.
No, because then that will keep changing. I mean, I suppose, yeah, but then we'd have to add. So if we wanted to say exactly what the date should be, if you assign that calendar to a local variable, the calendar get instance, and then use, it's a pain in the arse, but if you use calendar.set to set what we say the current time should be. So it's just set.
Okay. So let's say 2021.
So 4 is actually May.
Oh, yeah.
There's a bunch of, it's calendar.april.
It's not a nice API.
You don't need to worry about the others.
Okay.
Okay. So that gets you your current time. And then to get the start date, you reset the calendar basically. Such an elegant API.
Okay, and then
that, I believe, is that.
Okay. So let's run all the tests. Sales total is null. Get total is null. Okay, so we're not...
it needs to be returning. We'll have to set up a when on it then to return a number.
Yeah. So when sales total is...
So it's actually the method call is inside there. Yeah.
Oh, we actually have to...
Yeah, you can use matches though. Any number.
It has to be a sales total though, right?
Yeah.
So we don't care.
Oh, it's already got... No, you can. Yeah, you can just let it return 0. So that'll be fine.
Okay. So now it should hopefully fail for the right reasons.
Okay, so we're looking at April 20th, 2020, but it's going back 30 days
from
today. So that's exactly what we'd expect it to do. Brilliant. Okay, let's make it pass.
So can we... Is there a year?
It's yeah. So the first parameter is the date component that you're adding.
Okay. So we can say...
But don't forget, no, that will work because the end date is the current date. Yeah, that will work.
Okay.
Look at that.
Excellent.
Okay, superb. Now we've got one test for the start date. We want another test for the end date, but it's essentially this different assertions about the same setup and the same action. So we could do a little refactoring here to make the next test much easier to write.
So let's make reorder threshold a field. And the same for the sales history. And then if
you'll need the start date as well and end date too. So you'll need start date because we're referencing it further down.
Yeah. Okay. I guess we're going to need the calendar.
Hold fire on that.
Okay. Okay, yeah, I think I see what you're going to suggest. We can then pull this out to a setup method.
Hang on. It looks like we need why? Oh yeah, we need product as well if we're gonna.
Okay.
Yeah.
Oh yeah, of course.
That's rather a lot. Okay.
And then we can pull this to setup. Run the tests. Okay, so we're still parsing. And now we can write our next test. So our sales total ends 30 days after start date. Probably better having a relative test, yes. I think, rather than checking just the end date. Because if we change the period, like if we wanted to change back to what we currently have, then we would have to change 2 tests. It seems more likely that you might want to change the period rather than the duration, or just separating those 2 things out into 2 separate tests, the better thing. Hang on, we're calling setup in here, so let me just get rid of that. So we're going to calculate our reorder threshold for the product, and we want to check that our sales history, fetch sales total is called with our end date. Actually, no, what we want to do, we want to capture the start and the end date and compute the difference between them.
Do we? The danger
one
there
way
is
of
you're going to end up reproducing the logic of them. We know there are 30 days in April, so we know that the answer should be the 25th of May 2020. Otherwise we'll have to do date manipulation.
Okay, yeah, I see your point. Right. So
you could if you wanted to, just because the start date is already in the setup. I don't see why the end date shouldn't be in it as well.
Yeah. Well, let's
we can always refactor it.
Okay.
It must use the same calendar.
Yeah, it should, shouldn't it? Because of because it's going to populate milliseconds and nanoseconds. Okay, so we've got an end date.
Don't do an add. So the danger is you're reproducing the logic. So just say when should it be? It should be May the 25th, 2020.
Yeah. Calendar.May 25th. Yeah.
Your year is wrong.
Thank you.
Okay.
The benefits of pair programming.
Okay, that's exactly what we expect to happen.
Yeah, so we're a year out.
So we're currently basically we're saying it's today's date.
So instead, we want our end date to be our calendar a month ahead.
Days, I would do date.
Oh, yes, that's right.
If you do a month, then it'll be wrong some months. I think it's date.
Okay. That makes sense. Year, month, date.
Okay, brilliant. So we as Kent Beck puts it, we made the change easy, which was hard. And now we've made the easy change, and in doing that, we've modularized this thing quite a bit already. So there's already quite a lot of refactoring going on there. So we've got a whole bunch of pieces. We've done what the business needs. Oh, let's clean up our imports. So we've done what the business wanted, but while we're in here, let's see if we can add a bit of value and do a little bit more refactoring just to make life a little easier going forward for the next person that needs to change this. Now, there's something that's sort of catching my eye in reorder threshold. There's a couple of things going on here, and I'm generally suspicious of date-driven logic that's embedded with any other kind of logic. So I think this class should be responsible for doing this calculation of the threshold. I don't think it should be responsible for choosing the date range. The other thing we point out is we still got some balls of mud, particularly if you take a look in our REST service. That's still a bit of a ball of mud, isn't it? Unfortunately for us, it is not unit tested. So it is outside the scoop. It's outside the scoop of what is safe to refactor. So we could, if we were here, break this down. So basically repeat the process and say, well, what part of this needs to be in its own class, as it were. But at the moment, it's not safe to change it because it's not being directly unit tested. So we would need to add unit tests for this, which I would probably do. I would look at this and think that's probably going to be worth it in the long run.
Yeah.
Particularly with the change, the thing that you identified, Will, that really these services, ideally, they wouldn't be returning JSON strings because we're still binding our core logic to that JSON nonsense. And we'd like that all to be hidden. So ideally, we'd like to be able to turn this into maybe a generic class, and we can tell it what kind of object it's supposed to be returning. But right now, it's not safe to do that without writing tests specifically for this. So we'd have a bit more to go with this to get some tests around it. And then we'd abstract out the code that you identified, Will, that actually does connect to the internet. We'd put that in its own place, maybe, or maybe split it down into jobs. So maybe the first few lines are about building that parameter string.
Yeah, that's something that was
so on and so forth. So we could maybe split those out
to me
and break it down, but as a first priority, to find the offending code that actually connects to the internet. I would probably go from line 24 down to line 36 or line 35, and break all that out into its own class. That would make it safe for us to then change the signature of this to make it strongly typed, as you would suggest. I think that would be a refactoring worth doing. And then you just got all the HTTP client dependencies on their own. But we're not going to do that now because we're running short of time. What is bothering me at the moment is this reorder threshold. Let's actually do a little code review. Let's go through what we've got.
Yeah, let's
go methodically.
Start at the top, shall we?
Yeah. So here's our program.
Do a depth first search through our dependency.
Indeed. So this there's not a great deal we can do about this. You could probably no, we can't have a service. We have to have two services. So oh no, we've only got the one. Okay.
Well, we've got this one here.
Yeah. So I mean, if you wanted to extract that to a local variable to make it obvious what it is.
Yeah.
Your unit test would not be testing this, by the way.
Yeah, that's good. Yeah.
Be very. I get stung by this all the time where I'm running tests thinking, oh, it's all working, and I'm like, the code I'm changing is not being tested by the test that I'm running. Okay, but other than that, not a lot we can do with this one. What is reorder threshold? The one that I've just mentioned. What is our REST service needs work?
Look at that. Yeah, so we just reviewed that.
Sales history. What's that looking like now? Okay, I could probably if the JSON part of that was moved inside the sales service, I'd be quite happy with that.
Yeah,
His job
that'd be nice
to format those parameters and send the request.
Then that's what we were talking about, wasn't it? Having this typed service interface.
I mean, you could probably. So should we do this the dangerous way, just to demonstrate what we mean by that?
Yeah.
So what would the service look like if the JSON stuff of all the JSON nastiness was kept inside it?
Let's see what I can remember the order of generics. Is it afterwards?
Yeah.
There we go. So we would have a type parameter T that represents the object that this send request method will return. So rather than having this JSON call within each object that interacts with the sales service, all our services would be returning us actual objects that we can interact with.
So the sales service, if we instantiated it using the type parameter of sales total, then it would that method would return a sales total object like that.
Yeah.
And that would make this logic here much cleaner because it's not dealing with all that JSON nastiness. Because the format of the response should be of no
subject. Would look like that, wouldn't it? Not on that.
Yeah, it would look a bit like that. Yeah. Okay, but let's put it back so we've got something working. So that was the idea, and I totally agree with you there that really all of that all of that protocol, including the format of the data, belongs on the other side of that. What I think Michael Feathers refers to them as seams. We'd want a nice clean seam in the architecture behind which the nastiness of HTTP and JSON and stuff would be hidden. And that would probably be broken up as well. So we'd want to keep the format of the data separate from the protocol that we're using to fetch it. And we probably want to keep the format of the URL separate from that as well. So they probably end up as 3 separate concerns. How do we build that request? How are we processing that request, executing it or whatever? And what are we doing with the response are all part of that, but they're three parts of the same coin. Okay, so we've identified that this will probably need doing. Sales total doesn't do anything. It's just a data class. Warehouse, let's take a look at warehouse. Yeah, okay, so again, mentioning that JSON stuff, we'd want that to be hidden. But apart from that, it really doesn't do a lot, does it?
Barely does anything.
Barely
just
anything.
knows how to interact with the product service.
Well, quite. And then Stock Monitor itself is looking pretty good now. It knows very little, and that's where we wanted to get to. So let's just finish off by taking a look at the reorder threshold class, because that's something that we have got covered by test that we could do something with now. I'm trying to remember how I did this last. We'd like the date range stuff to end up in its own class. And there's different ways we could go about this. And so this is experimental. But one thing we could try is if we introduce a parameter object with a start date and an end date for fetch sales total. So we call it date range or something like that. So fetch sales total. So on
oh, you're right. Yes, yeah. I see what you're saying. Parameter object, and then we keep the start date, end date, date range. Let's have a look. What's it
usage
saying?
That is not safe to delete.
Oh,
of course. No, why would it not?
Oh, because of our matches and things like that.
Oh dear. That's annoying. When the test code is the thing holding you back. Okay, in that case, let's go around the houses. Let's do something similar to what we did last time. If we use extract delegate instead. So if you make start date and end date fields of this class.
Okay. To initialize them here. Yeah.
You can tell we're improvising now. And if we extract the code that sets those into its own method.
So all of that?
Yeah, all the date stuff, basically. Set date range. Are you running all?
No. There we go.
Good stuff. And now, let's go for extract delegate. It's still complaining. What's it missing? Oh, we need to take current time as well. Yeah.
All right. Yeah.
Yeah.
Okay.
That's for why does current time need a getter?
Yeah.
We're not referencing it anywhere else, are we?
So it's private. Current time, no.
Okay, let's see what happens.
Okay, so it's broken.
Because we're setting it in the. Then why would it create the date range? So we just need to create that in the constructor.
Yeah.
Because I noticed earlier that it was smart enough to figure that out.
Yeah.
Not this time, but that was a different refactoring, I think. Disappointing.
Okay, let's just run the text, see what happens there. Okay.
It said that it was generating, so that's a very misleading. I have a note to JetBrains. That's a very misleading message when we did the refactoring, because it suggested it was going to create all these getters and then didn't do that. Instead, it made them all public. So we can encapsulate those fields.
Yeah.
Should work.
Yeah, I guess we don't want to create setters. We have the set date range. Okay.
So let's see that work. See, what I really wanted to happen here, what would have been nice, is if we could have a class with a method on it that you give it today's date and it gives you a date range. That's what I was hoping to do, but unfortunately not. But it's all in one place now.
Yeah. It's quite messy still, I have to say, from a design perspective. It's not great, but it's heading in the right direction, I suppose. Like you say.
What if we actually set the date range? What if we call set date range in the constructor of this?
Yeah.
Try it.
Hang on. There's some. Okay, no, we've got current time here. Okay, so what were you suggesting?
So I'm just wondering, what if we call set date range in the constructor?
Yeah, we can do that. But we have to make sure that we instantiate the object within the calculate method. Otherwise,
yeah, that's absolutely fine.
Yeah.
So my goal here is not to make this swappable. My goal here is to have it on its own, basically.
Now, is there a refactoring? Okay, if I get rid of that, can I change this into a local variable? Is there a refactoring for that? Going the opposite way?
Try inline field.
Inline field. Inline and remove the field.
Because it accesses current time. So you need to assign current time to a field.
Okay. So can we do the same now?
It's still just.
Oh, if I swap the order.
It is accessible.
Okay. So if we assign this to.
It's going well, don't you think?
Yeah, not well. Okay. So that still works. Now we'll just get rid of this set date range and do this within the constructor. Yeah.
Okay, I'm a little happier about that. At least we've removed all of that date logic. Still needs some work though, I think.
Yeah, for sure.
For sure. But at least this date stuff is now hidden away.
Yeah, if it had a, I don't know. I'm not very happy with the name. Date range sounds like it should just be a data object with a.
It does.
some period.
Ideally, I would have had something that returns a date range.
Yeah, that would have been much better.
But we can't have everything we want. So look, I think we should leave it there. That's been really enlightening and interesting. We've got some tests around this thing, which is good. We've done quite a bit of refactoring to make it unit testable, and then done a little bit more refactoring while we're in here. And we've made the change that the business wanted, and we've done it in a test-driven way. So in that sense, I think we have succeeded at the exercise. Whether we're entirely happy with the design at the end, I don't know. That's for you to decide at home. I'm sure you'll make comments if you have any views on that, and there's lots to comment on. But I just wanted to thank Will Price. Thank you very much for joining in with this today on a Sunday afternoon. I'm sure you've got better things to do.
Not at all. It's been fun.
Excuse me,
Jason.
So anyway, yeah, that's just a brief sort of, I say brief, it's probably been a couple of hours now. That's a tour of the legacy code example. If you want to have a crack at this yourself, if you're a Java programmer, I'll post a link to the GitHub repo in the description below. So anyway, look, thank you very much for bearing with us, if you're still with us. Hope you're having a good weekend. Stay safe, and I'll speak to you in the next video diary. Say goodbye, Will.
Bye-bye.
You're supposed to say goodbye, Will. That's the joke.
Goodbye, Will.
Okay. Take care.